My name is Greenwald. This is React Native Code Reuse. And what we're going to talk about. So I've been doing React Native since React Native 13, which just makes me old. And in the last year, I've done a lot of React Native here at Wix. And what we're doing is we're building an app. We call it the Wix One app that we ship to both Android and iOS as a relatively single code base. We ship this app. But what's interesting about it is that we build the app with about 20 developers across multiple teams, multiple buildings, multiple countries, distributed kind of team, which gives us a fair amount of experience into what it takes to build a serious application in React Native. Quick survey. How many people here, show of hands, are writing apps in React Native? Okay, quite a bit. How many people are thinking about writing apps in React Native? How many people are like, screw that? Really? Okay, fine. So here's what we're going to talk about: how to reuse code in React Native. Or more importantly, how to build your app with an architecture that works with React Native. React Native promises, and it promises a lot. And oftentimes we wonder if it'll actually achieve that promise. The promise it makes, largely, is that you can reuse about 85% of your code. This quote that I have on the screen, I stole from a blog post that somebody at Facebook wrote about one of the apps that they wrote. And what they mean is that they were able to reuse about 85% of their code across Android and iOS. And that's very impressive. I don't need to convince you that it's important to reuse code. That's well understood and well known, that you should not repeat yourself because it's redundant. The question that you probably are asking yourself is not, do I want to reuse code, but can it really be done? Is that something that I can do, or is that just something that Facebook can do because they're Facebook and they can do whatever they want? And the answer in our experience at Wix is yes, it can be done, with caveats. There are problems occasionally. There are things that you won't be able to do, especially if you get more sophisticated and try to build really first-class applications with a lot of native code. You might need to do certain things that are only for iOS and certain things for only Android. But by and large, the 85% number, I did not measure it, but in my experience, does not seem overly aggressive. I think that we may have even, at least in some parts of our code, gotten more than 85%. Of course, when we talk about reuse of code in React Native, what we're usually talking about is Android versus iOS. I have two platforms. I want to ship an Android app, I want to ship an iOS app, and I need to reuse a lot of my code because I don't want to write it twice. But there are other kinds of code reuse in React Native, and oftentimes when I talk about React Native, or even when I'm not, people ask me, can I reuse code in my web app? I have a React web app. Can I share code? I have, it's almost the same thing maybe, or there's a lot of reuse or business logic. Can I stick my React app inside my React web app inside my native code? How does that work? I have no idea. So we'll talk a little bit about that. And of course, you may have multiple React Native projects and want to reuse code across those projects, just like you do in every other software development environment. You have some boilerplate or reusable code that you must reuse in multiple projects. And you can do that as well, but we'll talk about how. Let's start with talking about Android and iOS. Of course, the biggest draw, what may have made you come to React Native at first, what may have made you come here tonight, is to hear about how to share code between Android and iOS. Well, React Native essentially gives you two ways to do that. Number one, the platform module. It's something you import in your code when you decide that, okay, all this is the same, all this code, it's the same for Android and iOS, but oh, right here, I actually need to have a different view for Android and a different view for iOS. What can I do? So I can import the platform module from React Native and use it. Inside the platform module, there's an OS variable that will be either iOS or Android or maybe something else if you so dare to use Windows. And you can then use conditional statements. Here I have, short circuiting, but you can use ternary operator, you can use if statements, you can do whatever you want. It's just a variable. Now these get run at runtime. Okay, so at runtime, your application runs. If this is in a render function, which it is in this example, it runs every single time. The render, it has to check, am I in iOS? Am I in Android? What do I want to show? This works, and it's often a handy solution. There's another solution React Native gives you, what we call the file name suffixes. That's what I call them. I don't know what other people call them. I don't know if there's an official name. But what it means is that the React Native packager, which is what compiles your code, it turns it into a single bundle and possibly minifies it if you're in production. The packager is smart, and it decides whether it's packaging for iOS or Android, and then will choose specific files based on what your target platform is. So if you name a file, something.android.js, that file will only be bundled in the Android application. If you name a file something.ios.js, it will only be in the iOS version. And of course, if you don't put a suffix at all, it goes in both. What does this mean? Well, in the example I have on the screen, I have an input box component, which is completely different on iOS and Android. I decided that they don't even look at all the same. So I made two files, inputbox.android.js, inputbox.ios.js, and I import them in Meme Builder. Okay? And when I import them, I don't say that I want the Android or iOS. I don't care, actually. I just want inputbox. The packager is responsible for saying, wait, you're building for iOS? I'll give you the iOS version. You're building for Android? I'll give you the Android version. Okay? Now, this is really cool. It's a little bit magical, a little bit confusing sometimes, but it works, and it works very well. It allows you to have one code base with largely the same code, and here and there you have two files where you would have had one, and those two files differ. And then everywhere else where that file is imported, it doesn't know, it doesn't care, it's just shared. I'm going to take a moment to go a little bit off here before we talk about which one's better or which one you should use to point out that you probably, or maybe if you're an object-oriented programmer, be tempted right about now to say, this is great, I can use inheritance. I'm going to make like a base input box class, and then I'm going to inherit one for Android and one for iOS with two implementations. And then I can have shared code inside the input box as well. So I have like common input box stuff, and then some places I override some methods for input box Android, input box iOS, and it's brilliant, right? Not so much, because you started with two files, which was complicated enough. Now you have three, which is even more complicated. You have to maintain them. You have a bug, you have to figure out where it is. You don't know which one it's in. Your IDE can't follow the inheritance. Your code's complicated, and it's clumsy. If you use composition, and we'll talk about how to make your components small enough soon so that you can do that, but if you use composition where you just import separate input box in what I have here is the meme builder, but really any component that uses the input box just imports one or the other and compose views of little pieces that are small enough that they don't need to use inheritance. Your code will be easier to maintain, cleaner, and easier to read, most importantly. So, recommendation. In any case, the more important question is, which one should I use? Should I do the platform module, or should I use file name suffixes? The answer, like all questions, is it depends, and it depends on a judgment call that you'll gain with experience. What you need to bear in mind is that the platform module runs at runtime. Every single time you look at the platform module, and if it's in a render function, it's basically all the time. Every time you look at the platform module, you're checking again, what platform am I on, which one should I show? How much of a performance hog is that? Profile and see how much you're using it, and it'll depend. Probably not that much, but still. Why are you doing that? The file name suffixes happens at compile time, which is really semantically more logical. Because what React Native is giving you is not a way to have one code base that runs on both platforms, but to have one skill set, learn once, write anywhere. You have one skill set, you write for two platforms, you deliver two applications, and those two applications should be built for their appropriate target. What you have here, semantically, is not a case of, oh, well, sometimes we display this and sometimes we display that. No, you always display the right thing. It's just that on different platforms, in different applications, you have different things. So the fact that we gave you a nice way to have one code base instead of two code bases doesn't mean you should abuse it and have one file that then checks what platform it's on, which is both ugly and not semantic. So I generally prefer file name suffixes. However, file name suffixes means that you have two files that you have to maintain, two files that you have to test. A little bit more confusing and a little bit harder to remember where you are. Sometimes people update one without updating the other. So if you're afraid of that maintenance nightmare and it's something small, feel free to use the platform module. It's there for you to use. The most important thing to think about when you go ahead and build a React Native application is, like Guy said, the architecture. The architecture, of course, matters in general, but it matters a lot when it comes to deciding or realizing this code reuse benefit. You want to reuse code, and you want to be able to reuse code, you need to make sure that you will have an architecture that allows you to do so optimally. A couple of points to bear in mind while you architect your app. Keep your logic out of views. Okay? Think about this for a minute. In React applications, everything's JavaScript. So you don't have this like HTML and JavaScript separation. Everything's JavaScript. Your JSX is JavaScript. It's great. I can put logic right inside my component file. Don't. You'd kill somebody before you put JavaScript in your HTML template in an Angular app, right? Right. Of course. So why are you doing it in React? You're polluting your views with logic that doesn't belong there, that won't be reusable. Because most likely what's going to happen is when you decide to differ between Android and iOS, when you get to that point, what's going to differ is your view, not your logic. And so if you polluted your views with logic, then you're going to have to pull it all out. And it's hard to test, by the way. So if you're doing tests, which you should, you're going to have that trouble as well. So if you keep your logic out of your views, which you should, you'll find that your logic will be cross-platform. We'll get to that soon. And it'll be completely reusable. It's just JavaScript. And your views they're just slapping data on the screen. So you can make them differ for Android and iOS. Which brings us to our next point. Use what we sometimes call presenters and dispatchers. If you're not familiar with the pattern, it's not so important. The idea here is that you don't put your formatting, your deciding how to display things, your concatenation and your string, and you're massaging the data, and you're building strings, and you're formatting things. Don't do that in the view. You have a presenter layer, which can be a class or a service, or you can use reselect if you use Redux or whatever you want. The point is that you have a JavaScript layer that's just pure JavaScript, and that's where you figure out what you want to show. And that's where you decide what and how it's going to look. The actual laying it out on the screen is what happens in the view. But the preparation of the data, the massaging of the data, if you have a raw state and you need to massage it before you show it, you do that in the presenter layer, we call it. And the dispatcher is a term we coined to refer to the other direction. Oftentimes, in the case of Redux, you're dispatching actions. In other cases, you're doing things. And when you do things, oftentimes you need to marshal data from the screen, from input boxes or whatever, before you send it off to a server or something. Don't do that marshaling in the view layer. You're tempted to because it's fast, but then you won't be able to reuse it. Separate that into a separate file again. Put a function that calls that file, and in that file you can do your logic. Easier to test, easier to share. Your logic should be cross-platform. I haven't come across any examples where I really need to have separate logic. Sometimes I have a feature that only applies to one, which is fine, but I don't have logic where I need to say, okay, check what platform I'm on. If you do, then you might need to deal with it. But generally speaking, I don't have that. Logic is fairly universal. And if you structure your app this way, then it'll be easy to reuse your whole logic, just drop it in, and have separate views. And the final point is that you should have small and modular views. What this means is that if you look at most applications, even applications that look very different between iOS and Android, if you really think about them, what you find is that most of what you're seeing on the screen is the same. You have a different menu, a different top bar, a different bottom bar, a different thing on the side, a different organization of components, but that's it. Okay? The little pieces are the same. And so if you break your components into a couple of big components, then you have a tree, right? So you have a couple of big components that have a lot of components within them, and a lot of components within them, and a lot of components within them. And each one, you basically stick to the single responsibility principle. Each one does one thing and one thing well. Then those little pieces are building blocks that you can shuffle around, reuse, put together in all kinds of different ways, completely different ways for Android and iOS. Still have a very different view, essentially, but really with mostly code reuse. Most of the little pieces are the same, and they're just combined in different ways, or used or not used. Some are left out in Android, some are left out in iOS, et cetera. So instead of making these big views that have a ton in them, and then you have to completely separate them for Android and iOS, make your views a lot of little things. Just like in regular code, the single responsibility principle applies to all kinds of programming in general. If you keep your functions small, then you can reuse them. If you keep them big, you can't. Same thing here applies. Do it. So the architecture matters, okay? The architecture really matters when it comes to organizing your app in a way that you'll be able to reuse a lot of code instead of a little code. The same applies when you get to web apps. You say, okay, great, I have a React Native app. Now I want to make a web app. Or I have a web app, but I want to make a React Native app. How much code can I reuse? That, again, depends on how you architectured it. If you architectured it well, if you kept your logic out of your views, if you structured your app in a smooth, clean way, you should be able to reuse quite a bit. Number one, reusable application logic, just like we said. Application logic should be reusable. Think about it from the beginning. This line of code that I'm writing, is this specific to Android, to iOS, or is this general? Should this be in a separate function somewhere? Okay? But realize that the minute you make a separate function and you put it somewhere else, you need to compile it for the web. Because React Native comes with a packager, and it's great. Okay, the packager just gives you like the ability to write ES, whatever, everything in the future. It comes with its own babble. You don't think about it. Everything works. Now you want to compile for the web. Now you need to think about, wait, this code I'm writing, how am I going to compile it? And if I have a separate module somewhere, which I'm about to recommend, if I have a separate module somewhere and I compile that to ES5, then I'm importing that into React Native now. Debugging isn't as fun. It's a little bit more expensive. Something you need to deal with. Not something that should stop you from doing it, unless you have maybe a single function. But if you have a fair amount of code, it's worthwhile. But something to realize that you're about to increase the complexity of your architecture. Don't let that stop you from creating a separate module. You might be tempted to make one big NPM module that has a web app in it and a React Native app in it. And that might seem like a good idea until you try to build it. Then you realize that React Native is actually compiling all of it, because the packager does that. And you have a kind of web that isn't cleanly separated. You don't know what goes to React Native, what goes to the web, what goes to both. Keep a separate module that's your common code. Okay? NPM install it in both. Of course, you have to have a build step for that. You have to compile it. It's a little bit more work. But you will have clean separation. You'll know, okay, this is code I'm writing here. This is code I'm going to put in a comment because I need to do that. When you do make a separate module, you're going to deal with npm link problems. You know, how many people here have used npm link? Not so many, but good for you. npm link essentially is what allows you to work on a dependency and the app that includes the dependency at the same time on your local machine. You say, okay, I'm working on this. I want to see it. I'm working on this little dependency, and then I'm including it in this module. I don't want to have to publish this every time and then pull it into my parent app to see the changes. So npm link gets around this problem, but except that it doesn't really work on React Native. There are workarounds. There are kind of third-party solutions. There are all kinds of tricks you can do. I welcome you to look into them, but understand that it will be a little less smooth in the beginning. Hopefully things will get better on that front. But again, more complication, more complexity. Is it worth it? I think so. I think largely it is. But something that you should realize doesn't come for free. And then finally, we think about what happens when I have multiple projects. I may have several projects that use the same code. I may have one big project like Wix has that uses a lot of little components that then share some other common code. And things get, surprisingly, the most complicated on this side. Android and iOS sharing, React Native is made for that. Sharing with the web app, not such a big deal. This, surprisingly, is, I think, the hardest part of this whole talk. And so here, more than anything, the architecture matters. Thinking about what relies on React Native and what is just pure JavaScript. Thinking about what has native code in it and what doesn't. For example, when you have binaries, if I'm a dependency that gets included in some other app, and I rely on native code, not just JavaScript. I write my own native code, or I include a third-party app that has native code. Those binaries need to be what we call linked, connected to the binaries in the parent app that's going to include me. So unlike in most JavaScript code where you just say, okay, great, I'm Lodash, I'm a dependency in a million projects, and I want to rely on leftpad because that's what I do, I can just include it. Nobody's even going to know until leftpad gets unpublished. That doesn't work in React Native. Okay, you can't just include things. You can if they're just JavaScript, but if they have binaries, you need to tell the people that are relying on you that they need to include those binaries. It will slow down your iteration cycle a little bit, or a lot. You will sometimes deal with dependency hell. What happens is, unlike in NPM, regular NPM, like server applications, where you can have multiple versions of, say, any dependency coexisting in the app at the same time, NPM is built for that. React Native doesn't handle that. Okay, React Native compiles everything together. It wants you to have one version, which means if I'm a module and you're a module, you right there, you're a module, and we're both included in some other app, we better be relying on or compatible with the same version of React Native. I can't have my own version of React Native and he have his own version of React Native, which is really with the NPM like model. You can't do that. You got to use paired dependencies and make sure you're all together, because there's only going to be one version of React Native and other libraries, and that can cause problems. It also causes you to slow down. You can't upgrade as easily, because you have all these dependencies that have to be in the same version. So breaking your app into a lot of little modules, which is the NPM way, is a little bit harder on React Native, which makes you wonder if it's worthwhile. I think it is if you're big. In other words, we do it because we need to. Okay? Don't just start with it. Start with one application and think to yourself, oh wait, this needs to be shared with other applications. I'm going to introduce separate modules here. But I know that this is going to come with a cost, a bigger cost than just sharing with the web. And it'll slow me down a little bit and possibly have somebody who spends like half his time or more just maintaining that mess. Okay? Thank you to all those who do that here. But we have people that really spend a lot of time working on this because it's problematic and it takes a lot of effort. Now, when you have 20 people working together on an app that's really important and you can't really all work in one module, you do it. But understand the cost. So yes, code reuse is possible, but it's also not free. I think that the most important point here, in all these examples, whether you're sharing with the web or you're sharing between Android and iOS, which you're certainly, I hope, doing, and if you're getting really complex and you're sharing with other projects or you have multiple modules within your project, what you need to always think about from day one is the architecture. You need to do this always, but especially when it comes to code reuse. The better you architect your app, the more code you'll be able to reuse. You can always refactor later, of course, but refactoring also comes with a cost. The more debt you accrue, the harder it will be to get out of debt, and that interest is expensive. So think from the beginning about the architecture. Every time you write a line of code, think, where is this line of code going to run? What does this apply to? Does this apply only to the platform I'm thinking about right now, or does it apply to all the platforms? And if it's going to apply to other platforms, where do I need to put it? what layer of my application, what module do I need to put it in to make it work everywhere? Because ultimately, I think this is the most important thing to take from this talk, is that architecture matters. I'm going to go to questions if anybody has any. Okay, so the question is, how do you prepare the data? Very good question. So you have Redux, let's say. And if you have Redux, then you have map state to props. And map state to props seems like the place to prepare your data before the views. If you're not using Redux, then you probably don't have this question. You just have a place where you prepare the data. But if you're using Redux, you might wonder where. For us, what we often do is use Reselect, which is a library I encourage you to look into, which allows you to, inside the map state to props, to prepare your data for what the view is going to see. It also has all kinds of performance enhancements, memoization, fancy tricks, but you don't have to do that. You can also, when you stick your data into the state, or you can have, I'll give you a better example. You can have, let's say, classes or something that you get the data from state to props, you get it, and then in your render function, maybe you just pass it through a function. And that function lives outside. Of course, you're calling the function inside your view, which is not as beautiful, but at least you don't have the logic of the function in your view. You can test that function outside. You can share that function. So that's what I would recommend in that case. So the question here is, how do we structure the code? We obviously have the iOS and Android in the same repo. Do we also have the web app inside the repo? The answer is, doesn't matter. Okay? Some people like mono repos. Some people like to put everything in the same repo. Okay? Some people like to separate them. It's not so much a question about repos here as a question of modules, NPM modules. Definitely your web app and your React Native app are two modules. Okay? And if there's shared code, there's a third in terms of NPM. Now, whether you have in the root of your repository a folder for, mobile and a folder for web, and then within those you have apps, or you have them in separate repositories, actually doesn't really matter from both React and NPM standpoint. They don't care. Okay, your CI setup might care or might not, but that's it. In some cases, we do have things in the same repo. Sometimes we even have like server and statics code in the same repo, and oftentimes we separate them. So a question of, is it the same team working on it? Is it not the same team working on it? Do you want to have your history mixed or not? Up to you. The question is, do you put your mobile web next to your web? Do you put your mobile web next to your native code? In other words, mobile web is somewhere in between. Is it mobile or is it web? Right? I think it's web. Okay, it's web because architecturally and structurally and code-wise it's web. It's just a responsive view. You may have an adaptive view or a responsive view or whatever, it doesn't matter. But ultimately you have a code base that serves HTML, JavaScript, CSS, and then another code base that's compiled for native, completely different. It's shipped differently. When you ship your native code, at the end of the day, React Native, as much as it tries to be webby, you still have to submit them to the App Store, right? But the mobile web and the regular web get deployed together. So from my perspective, they're actually one project with possibly different views or not. Again, it's really up to you, though. There's no rule there. React Native doesn't have an opinion on that. Okay, so the question, if I understand correctly, and tell me if I'm wrong, is you have an existing code base that does, say, React.create class to create elements using just plain JavaScript. You're not using JSX. Can you do that in React Native as well? So you cannot, it's not recommended that you try to use the same code for creating the elements because they're completely different elements. But you don't have to use JSX. This is not really so much React Native's opinion. This is just React, okay? Ultimately, there's a compiler that compiles the JSX. And Babel has a compiler, plugins for JSX, compiles the JSX into JavaScript. It compiles it into the React.create class statements. Okay? If you prefer to write React.create class, you can. You're still going to have to use the React Native components, okay, like view and text and whatever, instead of div and, okay? But you want to write React.create class, you can. I don't think there's any benefit of it other than not liking JSX for religious reasons. I can't. JSX is nice and clean and easier, and I don't know anybody at this point, now that it's 2016, that will start with writing the old way. The old way is available to you, and you might have legacy code like that, but you may as well write the new code the new way. And of course, you can always mix and match. That's a very good question. The question is, do we recommend writing for Android and iOS simultaneously or one after the other? So I'll give you a little history. When React Native started, it shipped for iOS first, okay? Android didn't land for I don't think 6 months or so. When I started React Native around React Native 13, things were very, very raw. Android didn't really work, okay? Even iOS was kind of iffy. And at that point, we started with iOS first. We said we'll deal with Android soon, okay? And so we shipped iOS first, and then we dealt with Android. The nice thing about doing that was that we were very impressed by the fact that when we decided, okay, now let's focus on Android, it worked out of the box. about 90% for free. We didn't have to do anything. We weren't sure it would really live up to its promise, and it did, okay? At the same time, at this point, we don't recommend doing that anymore. At this point, moving forward, we do the same at the same time because it's a little bit faster. Why do that? Your users won't be happy. They want both at the same time, and there isn't really a cost. I actually did a workshop on Sunday and showed people who were very impressed. You can have both simulators open on your device at the same exact time. And if you have enough monitors, which hopefully you do, you can write code in your IDE and see both of them update in real time together and make sure you didn't just break anything. And that's wonderful. And there's no reason not to do that. They should be tested together. I once worked at a company where people would tell us that if they released a feature for iOS and then they released the feature for Android 2 weeks later, they'd get users complaining. People would be like, my wife already has the feature and I don't, I'm pissed off. Don't be that company. How do I test my React components? That's a trick question. You do not just do that. Okay, I really want to give a talk on that, but I think we're short on time. So that's a very long question, but right now we're using Enzyme for our React components. How many people are familiar with Enzyme? So Enzyme is Airbnb's, thank you. Enzyme is Airbnb's library utility for testing React components. And it's a great library. There are limitations, without getting too deep into it, there are limitations that are inherent in React Native that limit you, that stop you from running actual React Native code in Node, which is where your unit tests will run. So your unit tests will be really fast. They'll run in Node, and the logic, by the way, if you stick to what I said about the logic, keeping the logic outside your views, it'll be great because you'll be able to test all your logic as if it's just the web app. It doesn't matter. Jasmine, Mocha, I don't care. It's just JavaScript. Your views are a little bit trickier because even if you use Enzyme, you can only shallow render. For those of you familiar with Enzyme, know what I'm talking about. You can only shallow render because you can't actually render native components in Node. They're not meaningful, and you can't run like a JS DOM like you can for at least there isn't one yet that you can run for React Native inside Node. But even the shallow render does yield a lot of benefits, and we found, and recently we've gotten much better at doing this. There's a library that was written mostly by Ophir, who's probably here somewhere. It's called Enzyme Drivers. You can find it on GitHub, github/wix/enzyme drivers, and it helps abstract away a lot of the boilerplate. One of the problems with dealing with Enzyme for React Native is that you have to do a lot of mocking of all the native stuff. And mocking's not fun, okay? And Enzyme also gives you this kind of train wreck of, in order to see an element, you have to do this dot, this dot, this dot, this dot, props, and then invoke a couple of functions, and then look at it. And so Enzyme Drivers attempts to give you easy, quick, very simple ways to write tests. And since I started using it, I've been total convert. Now I just write component tests. I write tons of component tests now for pretty much everything. It's a lot of fun. I recommend you check it out if anybody wants to talk about it. Ophir, raise your hand. Please tell me you didn't leave. You there? I can't see the lights. Talk to Ophir. Anything else? Good. We got to stop. Bye, guys. Thanks for listening to me.